Well, hi everyone. All right, parent functions and transformations is the topic of the day, and I'm just going to draw fairly quick graphs of these, but one of the parent functions is the absolute value function. Oh, by the way, I don't know if you saw or not, I have included an attachment that has this if you wanted to print this out. Unless your initials are GR and your printer's not working and you're going to have to write it out by hand, which is kind of a bummer. But anyway, I digress. And so we have the absolute value function. This is the parent function of it. There's nothing being really done to it. It's nothing being added or multiplied or subtracted from this function. So f of x equals the absolute value of x. Now, the absolute value of 0 is 0. The absolute value of 1 is 1. 2 is 2. 3 and 3 is so forth. So I'm going to make sure to hit those diagonals of those squares that splits the first quadrant right in half, right there. Okay. Now, the absolute value of negative 1 is still positive 1. Absolute value of negative 2 is positive 2. So there is this one. And again, we'll split those diagonals right in half, and we cut the second quadrant in half diagonally. So this is the parent function for absolute value. The parent function for square root. Remember, we're talking real number lines here on our two axes, so we cannot be negative under here. 0, the square root of 0 is 0. Square root of 1 is 1. Square root of 2 is like 1.4. Square root of 3 is 1.7. Square root of 4 is 2. That's exciting. We're getting on to another one. Square root of 5, I don't know. 2.2 or so. But I'm gonna go. It's curving like this, and I'm gonna go up to. But do remember the 1 is from the parent function. Remember the 4 2. I'm gonna go 9 3 because square root of 9 is 3. 5 6 7 8 9 1 2 3 up here. So it's always increasing, but it is increasing. It gets slower and slower on the increase here. So that is the square root function. Quadratic. Oh, this is the parent square root function. All right, this is the quadratic. All right, 0 squared is 0, 1 squared is 1, 2 squared is 2, 3, 4, 3 squared is 9, 4, 5, 6, 7, 8, 9. Negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is 9. Okay, so that's what the parent function for, and I don't think anybody is too awfully surprised by that, for the quadratic. Now, I just went over 1 and over 2 and up 4, over 3. And I don't know if you ever knew this pattern, but you increase by 1, then you increase by 3, and then you increase by 5. You increase by the odds for this one. Nothing's being multiplied by x squared. This is a cubic function for our parent function. And 0 to the third power is 0. 1 to the third power is 1. 2 to the third power is 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1 to the third power is negative 1. Negative 2 to the third power is negative 8. Negative 3 to the third power is negative 27, so it's way beyond our grid here. Well, negative 27 down here, I should say. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so when I graph this, it curves right at the origin here and then goes up very rapidly, because the next point on integer values is 27 for the y coordinate. So alright, so there's the cubic function. Now, this is the reciprocal, parent reciprocal function. And let's see, if I do 1 divided by 0, it's undefined. 1 divided by 1 is 1. 1 divided by 2 is 1/2. 1 divided by 3 is 1/3. So we're talking asymptotes here. And the way it looks, and if you'll notice, 1 divided by 1/2 is actually 2. It's a reciprocal 1/2. 1 divided by 1/3 is 3. So it follows real close, but it hits 1, 1, the parent function, right here. And then it gets really close to the y-axis as you go left and up. As you go right and down, you get really close to the x-axis. You never can touch it, though. That's 0. You're not allowed to divide by 0. Okay. Now, but we do have a negative side here. 1 divided by negative 1 is negative 1. 1 divided by negative 2 is negative 1/2. And negative 1/3, negative 1/4, and so on and so on. And it's behaving the same way here. Only it's going down there. So this is what the reciprocal function looks like. And then f of x equals the greatest integer function. We've already done this pretty extensively, at least with the parent function, and a little bit of transformations. So, remember, there's our keystone there. Alright, I'll do those. Oh, by the way, it is my son's birthday today. You guys have taken your test today. It's December 10th still. And I told him I would mention that. So, there. My job is done. Okay, so the greatest integer function. I'll fill that with it. And then we're going to graph, let's transform these a little bit. Let's play around with the absolute value function first. If I want to graph f of x equals the absolute value of x minus 3, all I'm going to do is shift the parent function 3 units right. So instead of being at 0, 0, it's 1, 2, 3, the bending place, the vertex, it's going to be at 3, 0. I'll just hit those diagonals right there. Now, let's say let's make g of x equal to x cubed minus 2. Okay, that means I'm going to shift the cubic function 2 units. And when it's not inside the cube with the x, that's up and down. So I'm going to shift it 2 units down. And if you'll recall, so I'm just going to be going here. And the first one, we went 1 up and 1 over. Then we went 2 over and 8 up, right? 1, 2, 3, 4, 5, 6, 7, 8. And I went 1 unit down from 1 unit right, and then 8. That's 1, 2, 3, 4, 5, 6, 7, 8. So I'm just graphing it like I did before, only I'm not at the origin. Just figuring out where that center place is. It looks something like this. All right. I want to do a little something different here. If I were to, let's try f of x equals the negative square root of x. Okay, so you know where you would have x, I'm going to mess around with this, the square root of x, and then the negative square root of x. Let's just kind of put all three in, and then we'll graph this ordered pair from the first and third columns. So 0, square root of 0 is 0, negative square root of 0 is 0. If I use 1, square root of 1 is 1, negative square root of 1 is negative 1. Let's go with 4. Square root of 4 is 2, and the opposite of that is negative 2. Let's try 9. Remember, those were kind of the ones that gave us the integer values, because these are perfect squares. Square root of 9 is 3, and that's the negative square root of 3. So, I'm going to plot the first and third columns here for my coordinates. So 0, 0, 1, negative 1, 4, 3, 4, negative 2, and 1, 2, let's see, 5, 6, 7, 8, 9, 1, 2, negative 3. So now the square root function has just been flipped over the x-axis, and flipped is not as precise a term language there. So let's say it reflects over the x-axis. Here's our reflection when we put that negative out front there. Oops, wrong thing. This is reflected over the x-axis. Okay, let's graph one more. Maybe two more. Let's do f of x equals 1/2 x squared. So, you know where we were, 0, 0 is still a point, but where we went 1, 1, now I think we're only going over 1 and up a half unit. And here we're going half unit there. I'll do the symmetry side next after this. When I go 2, 2 squared is 4, but half of 4 is 2. 3 squared is 9. Half of 9 is 4 1/2. 3, 4 1/2. 4 squared is 16. Half of 16 is 5, 6, 7, 8. So 4, 8. 1, 2, 3. Negative 4, 8. This 4.5 right there. Go over to here. So in the red, I've got f of x equals 1/2 x squared. Now, I'm going to just draw in blue here. And we had the 1, 1, the 2, 4, the 3, 9. It's right here. So do you notice how this actually got wider? And we're compressing it. We're pressing it down. When we press down the parent function, this is what happens. So this is what we have on the other paper, but it's kind of good to look at it on one. So we're taking this blue one and we're just pressing it down, and it spreads out when you do that. Let me put one more on here. I'll do that in black. Let's say g of x equals 2x squared. So where it was 1, 1 now it's 1, 2. Where it was 2, 4, now it's 2, 8. 1, 5, 6, 7, 8. So I got a couple on there now. Okay, so in black here is g of x equals 2x squared. It still goes to the origin. Notice how it is, it's thinner, I guess. But now that's like we're stretching it. We're actually stretching it. If you were like to hold these blue ends up and stretch it, it would become thinner. Not a very good demonstration, but it becomes thinner because of that. All right. Now, the last thing I want to do is just take a look at some of the... I made a few graphs here, and I want to look at those and just try to come up with, see if we've learned enough maybe about to come up with the equations of what these graphs are. Okay, but the negative reflects numbers. We should generalize that. Let's say it's A. If A is less than 1 and greater than 0, it is going to compress and make wider the graph. If the number is bigger than 1, I'm actually going to put absolute values because the negatives will just reflect it. So if we do it with absolute value, we'll make a better generalization. If we have the absolute value of A is greater than 1, we are actually going to stretch the graph. And that will make the graph appear thinner. Okay? So, and then you kind of look at, if you know what the parent function is doing. So this is an absolute value. You've got the two lines meeting. This is an absolute value. So I'm going to just call this f of x equals, and I know before we'd go 1 and 1. I'm going to put a negative out here. We'd go negative 1, and then we'd go 1 when we were going up. We flip it, we go over and down with the negative. But we're not going down 1, we're going down 2. That's 2 units. So that is the factor that it's being multiplied by. It's an absolute value, and this point is what? 3, 3, 3 here. So we shifted 3 units right, which x minus 3 will do that, and we shifted 3 units up. So if you can just figure out when it should be 1 and it's 2, 1 times 2 is 2. If it's half and it's Mike Whiter out here, 1 times a half is a half. Whatever that is, whatever that first unit is kind of what your multiplier is out here. Okay. Let's take a look at this one. This looks like a cubic. And it's been moved. So I'm going to say x and then plus or minus something cubed. So I'm just going to, just to get started. 1, 2, looks like this is where the middle of the thing is. We've shifted it 2 units left, so that's x plus 2, and we shifted it 1 unit down, so that's minus. My question is, did we move it some? And I think we did. This looks like 1. Remember, the first time we did it, we went 1, 1. 1 and down 1. Looks like we're going about half that. When we go over 1, we're going like half a unit. And the way we could tell, where is it? Let's look at our parent function. The 2 was 8, right? When we went 2 units over, it was 8. Well, if I go 2 units over here, I'm going up 1, 2, 3, 4. So yeah, that's half of 8. So I'm pretty sure that's half. Now my next question is the direction the same way? And it's not. This is going down to up. This one's going up to down. We have flipped it. So that is negative 1/2 to do that reflection. Alright, this one I think looks like a square root function. It looks like it's been multiplied by something. It's been kind of stretched out a little bit. And looks like it's just been moved from the origin down to negative, or 0, negative 5. So I'm going to subtract 5. We've lowered it 5 units. Now, you remember on the square root of 1 is 1, right? When we went over, we'd be over 1. But now we're over 1. We're up 1, 2, 3. That's 3 units there for that first unit over. That tells me that's the multiplier. It is going up. It's increasing like the square root function does, so that's not being reflected. Okay. Had a couple more. I just wanted to show you this one, how it's skipping steps. You remember when the 2 was inside, it affected how wide the steps were. Now it's how the distance between the steps is being affected, and that's where the 2 would not be inside, but it would be outside. 2 times the absolute value of, not absolute value, that's not absolute value, the greatest integer function, the floor function of x. That's how that happens. So rather than just going up 1, we're doubling that. We're going up 2, and that's what the 2 out here does. This one, and with the greatest integer function, we have several options, but if I were to take this one and move it down 1, we would be at that origin. So I'm going to take that greatest integer function and I'm going to add 1 to it to make it go up. But the other thing I notice is the steps are 1 apart. I just changed the scale here a little bit. The steps are one apart, but instead of going up, they're going down. So it's like we flipped it over the x-axis. So let's just make that negative. Okay. Oh, that was a little longer than I thought it'd be. But that's all you got to do. Besides Alex. Make sure you get your Alex quota in by Monday afternoon. All right, guys. You take real good care of yourselves. And have a wonderful day and weekend. And I'll see you Monday. Bye-bye.